So this video is on the normal distribution worksheet number 3. This looks like our normal distribution worksheet number 2 from the other day. That one we were using the table of values. Today we're going to be using our graphing calculators. And to use the graphing calculators, our TI-84s, we're going to be looking for the blue second button. And then we're going to be looking for a button that has the word VARs written on it. Above that button in blue, you should have DISTR for distribution. Once you press that, you're going to get a drop-down menu. You're going to get a menu, and we're going to be wanting number 2, which is normal CDF, not normal PDF, which is going to be if we're trying to draw a curve. So we want normal CDF. And we're also going to want sometimes number 3, which is inverse norm. Now, when you're using the normal CDF, it's going to ask us for 4 values. It's going to ask us for a lower bound. I'm just going to write lower. It's going to ask us for an upper bound. Those are basically your interval you shaded that you're looking for. It is the lower is going to be the furthest to the left that your interval goes, and the upper is going to be the furthest to the right in terms of what you've shaded that interval. Then we're going to have something called mu, which is our mean. And then they're going to have sigma, which is our standard deviation. Now, when we're doing the inverse norm, that one, they're going to be asking us for something called area. And then they're going to ask us for our mean, mu, and our standard deviation, sigma. So let me just jot down for us. This mu is equal to our mean. The sigma is equal to our standard deviation. Now, when do I use which one? So for the normal CDF, that's what we do when we are looking at our table and we're looking at a particular interval with our z-score, and we're trying to find an area or a percent or a probability. So this one here is if we want to find area or probability or percent for a particular interval. The inverse norm we're going to use if we know the percent, we know the area, we know the probability, and we want to find the value that gave us that. So we know the area or probability or percent, and we want the value that gave us that, which could be a z-score if we're talking about a standard normal curve, or it's going to be an actual value that's related to our data. So the value that gave us, and I'm just going to say the area. Again, area, probability, percent are all the same values. So on our calculator, let me get the calculator over here for us to see. So on the calculator, we are going to be looking down here, and here is our second button, and over here is our VARs. That's what we're going to press. Okay. And then when I press it, okay, and so I'm hitting second and vars, you see the options here. So the options we want, again, are either number 2, normal CDF, or number 3, inverse norm. Okay, those are the ones we're going to be using. Okay, now let's say I did 2, and you just need to press 2. You don't have to arrow down to 2. Here it's asking you for the lower bound. Right now, this is using a standard normal curve. This is giving us negative infinity. That's how they're writing it. We're going to write it as negative 10 raised to the 99. This would be your upper bound. Then we have our mu and our standard deviation. Okay. Now, if I pressed number 3, you see it's giving us our area. Then for again, a standard normal curve, our mean would be 0 and our standard deviation would be 1. Okay. So let's take a look at, I'm going to do 1, 2, 3, 4 on this because they're all slightly different ways we're going to enter these in. So on this, and let me just make this a little bigger. Okay. So on this, for the first one, if I am wanting from 0 probability that something on a standard normal curve, and remember, a standard normal curve is going to have a mean of 0 and a standard deviation of 1. Okay, that's a standard normal curve. So we want to see what's the probability of something being from 0, the mean, to 3 in terms of standard deviation. So we're really going to be looking at this section here. Okay, this is the section we're going to be looking at. And so we are going to, and let me just kind of jot down here, this would have been 0. This over here would have been 3. So we're going to write normal CDF because I want to know what you're typing into the calculator. And then our lower bound is going to be 0. Our upper bound is going to be 3. And in this situation on 1 through 10 of this worksheet, it is a standard normal curve. So our mean is going to be 0 every time, and our standard deviation is going to be 1. And then we're going to put that into our calculator. So let me put the calculator back here. Okay. So I'm going to go to my normal CDF. My lower is 0. My upper is 3. They already have for my standard normal, my mean being 0 and my standard deviation being 1. And we see that we get a 0.49. And this is where I want you to give 4 numbers after the decimal. So if we're looking at these 4 numbers, we need to look at the 5th one to decide if the 6 stays or goes up. So this would be a 0.4987. That's what we're going to be writing. Okay, 0.4987. Okay. So just move this out of the way. So this is a 0.4987. That is our area. And just to show you that this does relate to our table, okay, if I'm going from 0 to 3, here's my table. I'm going to be using the table that I'm starting at my mean going out. So if I'm looking for 0 to 3, what I'm going to look for is, number 1, I'm going to be just in this column because we're not going to the nearest 100th. And I'm going to be going down to 3. And so right here, you see I'm at 0.4987, which is the value that we had. On the next one, I am going to be shading, and here I'm just going to do it this way so that so we are shading this whole section here. This one here, I am going to be going from -1 up So I am going to be starting here and I'm going to be shading everything over here. Okay. So I want that whole area. Now for this one, my upper bound is going to be basically, I'm going off to infinity. So how we're going to write that, we're not going to write it as infinity. We're going to write normal CDF. Lower bound -1, upper bound is infinity, but we're going to write it as 10 to the 99. And then our mean for all of these on 1 through 10 is standard normal. So 0 for our mean, 1 for our standard deviation. And we're going to put this into our calculator and we're going to see what we get. Okay. So I am going to put my lower bound, which is a -1, my upper bound, which is 10 raised to the 99. I'm going to keep all of those. And I see I get a 0.8413, 0.8413. So a 0.8413. Now, talking about my table, if I am looking at, let me just get this up. So just to show us on this one here, I'm going from -1 all the way to the other side of my mean. So I personally wouldn't use this table. I would have used this table. And we don't see a -1, but I'm going to go up to 1. And if I go to 1 on this, okay, I go to 1. You see right here, I am getting a 0.8413, which is what I had from my calculator. Okay, on number 3. So on number 3, this one isn't a pretty z-score. Okay, let's just say I'm here at a 2.2. It's going to be on this side. And we're going to be going less than. So we're going to be doing all of this is going to be shaded. And we want to find this area. And so what we're going to do is we're going to do a normal CDF. And our lower bound is going to be -infinity. So I'm going to do that as -10 to the 99. My upper bound is going to be 2.2. My mean is 0 and my standard deviation is 1. And I'm going to put that into our calculator. Okay. So I'm going to be putting in a -10 to the 99. I'm going to be changing this to a 2.2, keeping those. And whoops. Negative, not a minus. And I get a 0.9861. Okay, so I'm going to get a 0.9861 right here. Okay. So a 0.9681. 0.9861. Now, again, if I'm looking at the table, I want a whole half onto the other side to a 2.2. I would be using this table. I would be looking at 2.2. So here's 2.2. And you see that 2.2, sorry, that 2.2 is a 0.9861, which is what we got. Okay, number 4, last one of these, and then I'm going to do one that's not a standard normal. Okay, I'll keep that one in the screen. Okay, so on this one, we are going to, if this is my mean here, 0, I'm going to be on this side in terms of my standard deviation, so a -0.6, and let's say here for a 0.4. And we want the area or probability in between these. So I am going to type in normal CDF. My lower bound is a 0.6, my upper bound is a 0.4, my mean is 0, my standard deviation is 1. And I'm going to put that into the calculator. And so I'm going to have a negative 0.6, a 0.4, 0, and 1. And I end up getting a 0.8, a 0.381. And for this, let's get this up here. Again, this one here is going to get moved up to a 2 because of that 6. Okay. So 0.3812. Okay, so 0.3812. Now, if I was using the table, I would have found this section here for 0.6 on the first table and this section here, 0.4, and I would have added them together. So I would have looked here. I would have looked at 0.6, okay, 0.6, which would have been this 0.2257. I would have added that with the one for 0.4, which is a 0.1554, and that's going to add to the same thing I got here, 0.3812. Okay, so now I'm going to do one like, well, I'm going to do number 11. So 11, 12, 13, 14, these ones is not a standard normal curve. Our mean is not 0, our standard deviation is not 1. So in this case, my mean is 40. My standard deviation is 2. Okay, my standard deviation is 2. Now, if I'm drawing this out, this would have been a 42. This would have been a 44. This would have been a 46. Going the other way, 38, 36, 34. This is my mean. This would have been my z-score of 1, my z-score of 2, my z-score of 3, meaning I'm 1, 2, 3 standard deviations on the positive side above my mean. This would have been -1. This would have been -2 z-score. This would have been -3. Okay. Now, we needed the z-scores when we were doing it on the table. We don't need the z-scores when we're doing it on the graphing calculator. So I just need to know that I want from 42, okay, 42 up. Okay, so I want this area here is what I want. So I am going to do normal CDF. My lower bound is 42. My upper bound is infinity. So I'm going to do that as 10 to the 99. My mean is not 0. My mean is 40. My standard deviation is not a 1. My standard deviation is a 2. And I'm going to put that into the calculator. So when I put that into the calculator, I'm putting in a 42, 10 to the 99, which is really infinity. My mean is a 40. My standard deviation is a 2. I end up with a 0.156, and again, this 1586, this is going to push up, and this is going to be a 7, so 1.1587. Okay, so this is going to be a 0.1587. Now, I want to take a look at one on the back side. Okay. I'm going to be looking at, I'm going to start us off with number 20, and then I'm going to take a look at number 19. So on number 20, we want to be in the top 8%. So every year, the top 8% of the graduating seniors get awards. The grades of the graduates are normally distributed with a mean of 85, okay, and a standard deviation of 6. To the nearest 100th, okay, so we want to the nearest 100th. What is the lowest score that qualifies for an award? Well, if they're in the top 8%, I know they're going to be to the right of our mean, okay, because this would be the bottom 50. This would be the top 50%. And we want to be in the top 8%. Okay, so I'm going to zoom in a little. So let's just say it's here. And so this is going to be 0.08. That's the area that we want to fall in. Now, when we are doing this, we're going to be using the inverse norm because I know the area. I want the value that gave me that. What score gave me that? Now, when we do this, the calculator is going to find the area from here all the way up to wherever you want. So I'm not going to be trying to find the 0.08. I am going to be trying to find all of this, and all of that is going to be let me make it a little thinner, 0.92. Okay, I want 92% because 92% of the data is going to be in front of it. So we're going to do inverse norm. It's going to ask us for the area. I want to be in the top 8, but it starts from the left side. So I need to go 0.92 area is what I'm going to put in. My mean is 85. My standard deviation is 6. Okay, I'm going to put this into my calculator. So same spot, but this time I want number 3. My area, I'm going to be 0.92. I want 92% of the people below me. My mean was an 85, and our standard deviation, let me just double check. Our standard deviation is a 6. And you see that that's going to give me 93.43 is the score we need. Okay, so 93.43 is the score that they needed. So that represents right here, that would have been a 93.43. Now, if I was doing it on the tables, I would have used the second table that starts from the left side. And I'm not looking for a 0.92 as a z-score. I'm looking for a 0.92 as an area. So I'm going to be, let me just kind of grab this. I'm going to be looking here for a 0.92. Okay. So a 0.92 would have been about, let me move this here. Okay, so it's going to be about here, 0.92, which would correspond with a 1.41 z-score about. Okay, so this would have been a 1.41 z-score. Now, what that means is we would have taken our 85, added basically 6, because that's our standard deviation, 1.41 times, that looks awful, sorry, 1.41 times. And if I put that in my calculator, 85 plus 6 times 1.41, I got, helps if I type it in right. Sorry, I typed it in wrong. I get a 93.46. You see, I'm slightly off of this because the area I found was not exactly a 92. It should have been a 1.4, well, really between a 1.40 and a 1.41, somewhere between there. And that's why my value here, if I was doing it from the table, was a little bit off. But the calculator gave me a more exact one there. Okay, now the other one I wanted to do, and this is the last one, is a very similar problem where we are going to know in an area or a percent that we're looking to find the value for. But this is going to be like with a race. It's a running race. And so for runners, understand that you want to get a faster time, which means actually a smaller time. So in this problem, we want to be in the top 16%. We have a mean of 63 and a standard deviation of 4 minutes. Okay. So our mean is 63. I'm just going to draw this out. So if I was going out one standard deviation, I'm going to add 1, 2, 3. 1, 2, 3. Okay, let me just this, if I was adding this on 4 minutes, this would have been 67 minutes. Add 4 minutes, 71 minutes, 75 minutes. Going the other direction, if I take off 4, this would have been 59 minutes. This would have been 55 minutes. This would have been 51 minutes. And so I don't know where it is on this, but what I want you to understand is when we want to be in the top 16%, unlike this, which means I want to be to the right of my mean because I want to score higher on the test. Since this is a race and you want to have a smaller score, I actually want to be on this curve. Okay, I'm just going to redraw it without the values there. So here, this is my 63. I want to be over here, 0.16. That's where we want to be because we want to be having a smaller time because that means we're faster. We got done in less time than other people. And so in this case, I'm actually, since we start from the left to the right, I'm actually going to put in the 0.16. Over here, I did not put in the 0.08 because I didn't want to be here at the bottom 8%. I wanted to be here at the top 8%. So in this situation, I'm going to do normal CDF. I'm going to have 0.16 as my area, 63 as my standard deviation, as my mean, I apologize, and 4 as my standard. I'm going to start again. I'm not writing normal CDF. We are doing inverse norm, okay? Inverse norm, because I know the area and I want the value. I want to know what is this value right here? What value is that? So inverse norm, my area I'm looking for is 0.16. My mean is 63. My standard deviation is 4. And then I'm going to put that into my calculator. Okay. So, let me get that. So my area is 0.16. My mean is a 63, and my standard deviation is 4. And I end up with a 0.5902. Okay, so I end up with a 59.02. In this case, they asked us to round to the nearest minute, so it's going to be about 59 minutes. And you'll see that that is to the left of my mean because I want a smaller score. So over here, this would have been 59 minutes. That's where I would have to be. 59 minutes or slower. 59 minutes or smaller value to be in the top 16%. And that's the end of this video. The rest of the problems, I'll post a key, but the rest of the problems you might want to try just to make sure you understand what you would be typing into your calculator.